Hi, I'm Simon, an anesthesiologist and founder of SCATS Education. I've helped hundreds of students crush their science classes and reach their dream grades. I know what it's like to not understand your professor and feel overwhelmed with this material. That is exactly why I created SCATS Education. Stick with me, and I'll help you achieve your goals like the students I've worked with before you.
So the first part in understanding the alcohols and phenols chapter is understanding the structure and nomenclature of alcohols. So what is an alcohol? An alcohol is any compound that has an OH on it. So for example, this is an alcohol because it has an OH. This is also an alcohol because it has an OH. And the name of the compound on the left is ethanol. The name of the compound on the right is cyclopentanol. So let's talk about naming. I'm going to remind you of the 4 basic steps to naming any compound. First, you want to assign a parent chain. Second, you want to name substituents. Third, you want to assign a locant to each substituent. And lastly, you want to assemble your substituents in alphabetical order. So let's work through these steps and see how it changes when it comes to with regards to alcohols. So when I have a regular alkane chain like this, we would name this pentane because it has 5 carbons. But if I add an OH group, now the name here is pentanol. So we replace the E with an ol. The reason why is because we have this OH group there. When identifying a parent chain, you want to make sure that you include the carbon that has the OH within your parent chain. So for example, if I have this, parent chain is this, the longest continuous string of carbons that we can find. And in this case, it's right here. This would be octane. But if I add an OH group, like that, now the parent chain has to include the carbon that is holding the OH. So my new parent chain is going to be right here. This is going to be hexanol. Next, let's talk about numbering. So when you're numbering your parent chain, you want to make sure that the OH group, the carbon that has the OH group, has the lowest possible number that you can assign it. So let's take a look at an example. Here is my parent chain. Now, if I number this, if I number it from left to right, this is the numbering that you would exhibit. 1, 2, 3, 4, 5, 6, and 7. This gives my OH group, the carbon that has the OH group, the lowest possible number, number 2. As opposed to if I number it from right to left, 1, 2, 3, 4, 5, 6, 7, that gives the carbon with the OH group a number 6, as opposed to the number 2 that we had originally. So in this case, the red numbering is correct and the blue numbering is incorrect. And again, we want to have the carbon with the OH group to have the lowest number. Next, let's talk about how to denote where the OH group is within the parent chain. So if I have this compound, the numbering here would be 1, 2, 3, 4, 5. You can go from right to left here. It does not matter in this case because it's a symmetrical compound and you'll still get a number 3 on the carbon with the OH. But the point here is that the parent chain name would be pentanol here. And since it's sitting on the 3rd carbon, we have to show that within the name. So how do we do that? You want to put the number 3 before the parent chain name, or you can even put it in front of the OL ending. So you can put penta 3-ol. Either of these is correct. Now a quick word on chiral centers. Just like any other compound in organic chemistry, you have to show what the chirality is for every single chiral center within the name. So for example, if I have this, so for this compound, what is my parent chain? My parent chain is right here. This group here is considered a substituent. Now to number it, it would be 1, 2, 3. Again, we want to have the carbon with the OH to have the lowest number possible, in this case, 1. So how do we name this? Well, this carbon right here is a chiral center, and I am telling you, in the essence of time, this is an R configuration here. So how do we name it? Well, first, let's start with the parent chain. This is a 3-carbon parent chain, and it has an OH group on it. So the parent chain name is going to be propanol. And on carbon number 3, we have this substituent. This is called a phenyl substituent because it's a benzene ring. So it's going to be a phenyl substituent. And it's on the 3rd carbon here. And on carbon number 2, we have a chlorine substituent. So this is going to be 2-chloro. So now let's put this all together with respect to the chiral center. So if I put this all together in terms of the alphabet, C is ahead of P in the alphabet. So it's going to be 2-chloro, 3-phenyl. And remember, you have to make sure that you identify where the OH group is within the compound in the parent chain. So you're going to put a -1 dash to signify that the OH is on the 1st carbon. Now we can't forget about the chirality, right? And so we have a chiral center that is R. So you just put an R in parentheses ahead of the entire name of the compound. And that's how you name this compound with a chiral center.
Next, let's learn about cyclic alcohols. What's nice about cyclic alcohols is that you always number the ring and where the OH group is as number 1. So you don't have to indicate where the OH is on a ring because you know that the OH group is sitting on the 1 carbon. So for example, if I have this will always be carbon number 1. If I have something that looks like this, I will number it 1, 2, 3. Again, remember, we always want to have other substituents on the lowest possible carbon. You should be familiar with primary, secondary, and tertiary alcohols. So the trend is very common in other chapters that you've learned in organic chemistry. So this would be a primary alcohol. Why? Because the alpha carbon, which has the OH group attached to it, has 1 R group. So if I have 2 R groups on the alpha carbon, this is a secondary. And as I said already, this is a primary. And then lastly, I have 3 R groups, like so. The alpha carbon, this would be a tertiary alcohol. And lastly, you should be familiar with the common name that you're going to hear throughout this entire chapter. It's called a phenol. A phenol is simply a benzene ring with an OH group attached to it like that. This is called a phenol. So next, I'm going to put an example on the board, and you can try to name it. So go ahead and pause the video here, try to name it, and once you unpause, you'll have the answer. All right, so to name any compound, we follow the 4 steps, which is first, you want to name and number the parent chain. After that, you want to name your substituents. Then you want to assign a locant to them, which is simply assigning a number, or the number carbon that they are sitting on. And then lastly, you want to assemble them in alphabetical order. So let's find the parent chain. So remember, the OH has to be included within the parent chain. The longest chain of carbons that we have in this compound is right here. And to number it, remember, we want to have that OH to have the lowest number of carbons. So I'm going to start from the left and move to the right. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is what? This is the parent chain here is going to be nonanol. And the OH is sitting on the 3rd carbon, so we put a 3 right there. So that's the name of the parent chain. Next, let's look at substituents. So we have 2 substituents here. We have these chlorines, and we have this ethyl group here. So since there's 2 chlorines, we put a dichloro as the name, and we have an ethyl here. That's how we name these substituents. Next, let's assign a locant. So the chlorines are sitting on carbon number 4. And since we have two of them, we put 4, comma 4, and then a dash. And then the ethyl, since it's sitting in carbon number 6, we put a 6 dash ethyl. And then lastly, let's assemble all of this. So C comes before E in the alphabet. So we're going to arrange this in alphabetical order. So we're going to say 4, comma 4, dichloro, dash 6, dash ethyl, dash 3. Now we're doing the parent chain. So dash 3, dash nonanol. And then remember, we always want to name our chiral centers. We want to assign their configuration. So on, just take my word for it this time, on carbon number 3, this is an R configuration. And on carbon number 6, this is also an R configuration. So we'll put ahead of the name, we'll put 3R, comma 6R. I'll put that in parentheses. And this is the full name of this compound.